Hello, everyone. Welcome back to Mr. Valencia's classroom. In this case, Mr. Valencia's virtual classroom. I hope everybody's doing great. We got to take some precautions. Let's stay safe, everybody. I miss all you guys. Pertaining to the state of Arizona, we're going to be doing this for at least until April 10th. If there's any changes going on, we'll definitely keep you updated on a daily basis. But for right now, we're gonna work like this. I'm gonna be posting videos using YouTube. I know that you guys, especially my students, let's face it, you guys are all about YouTube. You're YouTubers and TikTokers and this and that. So I'm gonna be doing a YouTube channel. Make sure you follow me. I will be sending your parents the link to every video. How this will work is just very similar as in classroom. We will go over the lesson just like you have here. Today we will be focusing on beginning on module 5 for 6th grade, and this is lesson 1. Okay, and our focus for today would be to find the area of parallelograms through rectangle facts. Right, and again, we're working with Eureka Math. Okay, which is the Engage New York. We do not own the rights for these, but Academy del Sol at Star Valley is using this type of math, all right, to help us understand and help with achievement and hopefully be successful in the AZM2, which is upcoming. Again, if there's any different changes to it, we'll move on from that. Before I start off anything, I want to set my expectations to you guys from online. I know everybody has ongoing issues, and maybe some of you don't have internet at home, don't have a device to access this information. Please stay in contact with me as soon as possible, so that we can come up with an arrangement. But while I'll be asking for you, my students, my focuses, we will be doing this just like in classroom. We will be label everything that I write in here. You guys will label it. Those will be your notes, okay? Just like in here, these will be your notes. And then by the end of that, you will have the famous word problem set, which in other words, we call it our homework. You will do your homework. Lesson 1 does have a backside, you guys. Remember, it does have a backside. Okay, just to let you know, homework does have a backside. Okay, and we're working again on module 5. Now, what I'll be asking for you students and parents is 2 things. You can either homework, once you're finished with it, you can have parents, you can either scan it and send it to me here. These are my 2 forms. You can either send it to my email, my work email, which is ivalencia@academydelsol.com. Okay, leave that for a few seconds. Maybe some of you already have it. Pause the video if you need to, or just send it to me through Class Dojo. Okay, I did mention you can scan or take pictures. Sorry about that. You can scan or take pictures of the work and send it to me. And students, you can also record a video. I don't have to see your ugly faces, JKA. You're all gorgeous and beautiful and handsome. You can record videos of a particular problem. For example, if you're having problem with number 4 on the homework, record a video explaining to me what you don't understand or what you need help with, or just send me a question through Class Dojo or email, and I'll either answer back with an email or most definitely back with a video to walk you through the problem, and so that we're all on the same page and we achieve academic achievement in math. All right, we all want to be on the same page. This is all new to us. We got to work with what we have, the tools that are being offered for us at the moment. Hopefully this doesn't last long. Okay, but we do got to take precaution with that COVID-19, aka the coronavirus. So for right now, we're going to work this way. Again, I will be sending a link to this. I am making a YouTube channel. Okay, I am making a YouTube channel. Maybe a few days from now, I will be going live. So if some students want to follow along, and send me questions as I'm doing the video, I can answer right away. So we will be improvising and hopefully making these lessons more effective as time goes by. This is trial and error for right now, but hopefully, let's get this done. All right, everybody. So we're going to begin again with lesson 1, which is the area of parallelograms through rectangle facts. Area of parallelograms. All right. Parallelograms are any shapes that have parallel lines to them. What are parallel lines? Well, parallel lines are any like these ones right here. For example, on this shape, parallel lines, that means that there are two lines going towards the same direction, like this top one and this bottom one. Okay, they're both going towards the same direction, same as these ones. This line right here and this line right here, they're going towards the same direction. If it continued forever, okay, they're parallel to each other. It's like if I place these two pins right here, these pins are parallel. Why? They're heading towards the same direction. It's if like I change them like this, they're parallel to each other. All right. Once we start doing this, we call this perpendicular. We're not going into that right now, but these are parallel lines. All right. Same thing for this one on the rectangle. We notice that this is a these are parallel lines, and these right here also are parallel lines. We look at this triangle. They're all going towards different directions. That lets us know that that is not a parallelogram. All right, there's not two pair of lines that are going towards the same direction. We look at this one right here. These two lines are going towards the same direction, top and bottom. That's a parallel lines. These two as well, they're traveling towards the same direction. Okay, those are parallel lines. These are not a parallelogram. Why? They're all going towards it. It'll intersect in here at some point. Okay, same thing here. They'll intersect at some point. So these are not parallelograms. All right, everything those are parallel lines. So I'm gonna ask you guys, write this down just to keep just a little note. It shows just a little sample of how two lines that are traveling to the same distance. That's why I put these little arrows at the end, which means they're traveling at the same distance. There's that little gap between them that equals parallel, just like here. That's parallel, that's parallel, that's parallel, and these are parallel. Same thing with this one, that's parallel right there. All right, those are parallel. Okay, if you have any questions with this, again, send me a question through Class Dojo, through my email, ivalencia@academyofthesoul.com. Okay, I'll be able to answer those questions. Okay, so let's jump right into it. Classwork, opening exercise, name each shape. So we have this shape right here. Okay, it's a three-sided shape. Okay, and this three-sided shape was introduced to us maybe first, second grade. Well, we know that this three-sided shape, it's called a triangle. Okay, it is a triangle, but if you notice here at the edge, and I'm going to point it out by putting an arrow there just so you in case, this right here, let me get a colored pencil just to highlight it out a little bit. I'm going to use a yellow. If you see right here, right there, it forms an angle. Okay, it forms an angle, and to let us know with that the angle it's forming has a little square on the edge. When it has that little square on the edge, it means that it's a 90-degree angle, and this represents 90 degrees. And when it's a 90-degree angle, that 90-degree angle has a specific name. We call that a right angle. Okay, that's a right angle. So since this triangle has a right angle, the appropriate name of this triangle, it's a right triangle. Okay, it's a right triangle. Why is it a right triangle? Because it has a right angle that makes up the entire triangle. All right, hopefully that lets us know every time it has this, it doesn't matter in which shape, that means that it's a right angle. Doesn't matter if it's pointing in a different direction. We look at this one, okay? This is the perfect example of a parallelogram. This bad boy has different names, all right? It's a parallelogram. Why? Because we have these lines right here, which are traveling traveling to the same distance, okay, same direction. Those are the infamous parallelograms. They're parallel to each other. They're standing next to each other, in other words. Okay, then we look at this one. We have, again, a three-sided shape. We call that a triangle. Right? Now, there's different things with triangles. Triangles are very specific, or they can be very basic. In this case, it's a triangle. If we look at it very closely, inside, and we're going deeper, inside you can see that there's actual angles. If you were to get a compass and measure this, you would actually be able to figure out how much every angle is worth, or what's the degree of it. Okay? It could be anywhere from 1 degree to 89 degrees. If you see, there's no square here, so there's no right angle triangle in here. But this is a triangle, okay? Or you can also just leave it as a triangle, or you can also call it an acute triangle, okay? Why acute triangle? All the angles in here are probably 89 degrees or less. And we will see this in the future. They'll do these little bubbles on the edges, and they'll put the actual degree in there to let you know what's the actual measurement of every angle. Okay, so it's a triangle. Okay, if you want to leave it just as triangle, awesome. We don't have to be that specific, or just call it an acute triangle if you want to go deeper and with more knowledge. All right, you go into the next one. Ooh, another parallelogram, right? It's another parallelogram. Or you guys call it, since you've learned it since kids, we call this a rectangle, right? So a rectangle is a parallelogram. A rectangle is the specific name. That's the thing. It's the specific name of this type of parallelogram. Why is it a parallelogram? It has parallel lines here, and it has parallel lines right there. So they're traveling to the same direction, okay? This is also a parallelogram. They didn't write it, but I'm going to have it here. We also call this a, excuse me, right there. We call this a rhombus, okay? We call this a rhombus, okay? A rhombus. And then the last one, this is also a parallelogram, and the very specific name to it, we call it a trapezoid. All right, this is a trapezoid, which is also a parallelogram. Okay, so these are the different names of the shapes that we have. Okay, these are the different shapes, and I'm gonna highlight here just in yellow, just so you see the parallels. These are parallel. Sorry about that. Okay, these are parallel. These are parallel, right? Same thing here, right? Using different colors just so you're able to see that these are parallel, right? They're traveling to the same direction. I don't know what color I'm using here. I think it's baby blue, but you guys know I'm colorblind. These are parallel. These are parallel. Okay. Just for the sake of this, just so you guys don't get confused from the beginning, these are not parallel, so I'm just changing the color. Okay. They're just showing you that there's a 90-degree angle right there. It cuts in the corner. Okay. So these three right here, number 1, number 2, and number 3, these are the 3 forms of parallelograms. There's more, like a square, okay? A square is also a parallelogram, okay? If I draw a square up here really quick, and it won't be neat and perfect, that's a parallelogram. If you notice these sides right here, they're parallel, and these right here are also parallel. Okay, so a square is also a parallelogram. There's the reds, which are, these are parallel lines, and the ones in blue or purple, those are also parallel. So a square is a very specific type of name of parallelogram. All right, these are them. Well, we're gonna jump now into our exercise, and this is what it's asking. Okay, if you have any questions on the top, please send it to me. I know I talk a lot. Okay, it's my first time doing this. We'll be getting better as we do this along. Okay, find the area. So I'm focusing right here on the instructions for exercise. On number 1, find the area of each parallelogram. So we've established that all these 3 are parallelograms. Below, note that the figures are not drawn to scale. When it says not drawn to scale, and I'm gonna highlight that. What it means when it says not drawn to scale, it means that they're not necessarily exactly 5 centimeters. It's not in reality 5 centimeters. If you notice here, I have a ruler, okay? And I'm gonna use this one, which is a little bit more transparent and easier for me to see. This is a ruler. The top units are centimeters. These bottom units are inches. I noticed that the units here on the problem, they are centimeters, okay? So if I were to measure it, and I'm gonna prove it to you why it's saying it's not to scale. If I actually measure this, this side is not actually 5 centimeters. In reality, it's 1 1/2 of a centimeter, okay? So if I measure the base, again, it's very close to, I'm gonna estimate it's almost 2 centimeters. Okay, and if I measure the height, it's almost 1.5 centimeters. So if you notice, numbers don't add up. That's what it means that it's not drawn to scale. When they say it's not drawn to scale, it means that it's not technically correct if you use a ruler. But just for the sake of practice, they put numbers here so that we actually practice of how to find the area of a parallelogram, all right? So you don't actually need a ruler for this. Okay, so we're gonna jump to this one. So right away, I'm gonna change my color to a red pen, okay? And our focus here is to find the area, okay? Area. What does area mean? Remember, ladies and gentlemen, okay? Area, I'm gonna do right here on the corner. Okay, I'm gonna draw a square just for example. Okay, square. Area means all the square feet or all the square inches or centimeters or the square units that are inside that shape. All right, in this case, if you notice, there's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, or traveling this direction. This is a 4 by 4, which we're doing length times width, right? Which is 4 times 4, which is 16 units squared. Okay. It's just an example. So I'm just showing you area. It's to find out how many squares are inside that shape. That's what we're doing with this one, trying to figure out how many squares are actually going to fit, I'm sorry, let me rephrase that, inside of each parallelogram. All right, so right off the bat, you guys, I'm gonna give you this formula. This is the formula to find the area of each parallelogram. Okay, very important. I'm gonna use A, which represents area, equals, okay, and this is the true formula for finding the area of parallelograms. A equals base times height, okay? Area equals base times height. So we need to know what's the base of the parallelogram, and we need to know what's the height, okay? And we're gonna multiply them. It's the same as saying A equals B times height. They're both the same. We're going to multiply the base and the height, and that will let us know what is the area of the parallelogram. All right, so we're going to focus back on here. Okay? And I'm going to be using colored pencils a lot, okay, to highlight this information. We're all on the same page. Okay, remember, if you have any questions, send me through Class Dojo or email. You can either type me a message or send me a video, whatever helps you. Okay, we have 3 different numbers on this parallelogram. Okay, we're only going to focus on the base and the height. This right here, which I'm using probably orange, which I'm highlighting in orange, which is being represented by the 6, your 6 centimeters is going to be your base. Okay, so remember, all these lessons, you guys, we've been working with replacing variables with numbers. That's the same thing we're going to be doing here. So in this case, 6 is going to be the base, which I use in orange, and your height, which is how tall it is, okay, is going to be this dotted line right here, which is being represented by the number 4 centimeters. So that right there, it'll be hard to see in yellow. I'll put an arrow right there. That is your height, okay, which is being represented by the number 4. Now, I didn't use I would have loved to write the word height with a yellow highlighter. I'm probably going to highlight this so you understand what I'm saying. They're tied together, okay? So your base, which is in orange for this parallelogram, is 6 centimeters, and your height is going to be 4. This one right here, we don't need to focus on for today, all right? This is more towards the future. All we have to find out, because it's the area, we have to do base times height. Same thing for this one. If we focus on the parallelogram here in the bottom, it's a little bit bigger parallelogram, right? Again, it's not drawn to scale, so this is just practice problems. I'm going to use another color now. I'll be using like a greenish yellow. This right here, which I'm highlighting, which is like green yellow, which is 25 meters, okay? That is your base, so the base is 25 meters. And I'm going to use baby blue. Which I highlighted right there. That is your height, which is being represented by the 8 meters. So it's 8 meters tall or 8 meters high, all right? Again, we're not caring about that 10 meters right now. We're going to leave it out there. And then we're going to focus on the last one, okay? I'm going to use now regular green, okay? Regular green. And I know it's because I looked at the color before I said it. This right here, what I highlighted, being represented by 12 feet. That is your base. And I'm going to use a purple. In this right here, what I highlighted, purple, which is being represented, means it's 7 feet tall. That is going to be your height. All right, that is going to be your height. So now we have that. If you see, there's similarities to all of these. Okay, this is your base right here for all 3 of these. Okay, I use colors to represent them, color coded. Okay, and this one, the units are centimeters. These are meters and these are feet. Sorry about that. These dotted lines right here help us. It's a big clue. It's called context clues. You can learn that in ELA. It lets you know how high the shape is or what's the height. Height, high. Okay, it lets you know this is 4, 8, and 7. And all we have to do for the area is multiply the base and the height. So we can go in and plug it in. Okay, now that we know. Okay, I'm going to use a different color now. Going back to blue or purple. We have our formula. It'll apply for all of them. Let's gonna focus on the first one, letter A. So let's focus on the formula. So A equals base times height. You can also write it like this if you want to. If you feel more comfortable writing it like this, by all means, write it like that. Okay. I go back here and I look, and my base is what? 6 centimeters. So I'm gonna go in and plug in A equals, and my base we said is 6 centimeters. And my height, now we can plug in the A, we need to find the height, and the height is 4. So I'm gonna multiply that 6 centimeters times 4 centimeters. Now we can multiply the 6 and the 4. A equals 6 times 4 is 24. And centimeters times centimeters is centimeters squared. Okay, and that's the area of that parallelogram. Okay, and remember, it's also squared because we're finding the area. How many squares fit inside this parallelogram? Well, inside this parallelogram, 24 squares fit inside that parallelogram. All right, 24. Make sure you put that square sign. All right, it'll be very important when it comes to the AZM2 that you write that square sign, so it lets them know that you're finding the area. All right, let's jump to the next one. Okay, using the same formula, A equals base times height. Okay, I think in here, I don't know what color this is. I think it's like a yellow-green. We've established that the yellow-green, the base is 25 meters. So I'm gonna replace the variable B with the number 25 meters. And I'm gonna multiply the height. And the height I think we did here in baby blue, we established that the height is 8 meters. So now we can multiply that. 25 times 8, if I'm doing my mental math correctly, it's 200, and meters times meters is m squared. So the area for this parallelogram is 200 meters squared. So inside this parallelogram, we're gonna find 200 of those squares. Okay, we multiply the base and the height, and we go to the last one. Okay, very last one here in our on this front side of the page, using the same formula. It's a different color. A equals base times height. That's the formula we've been focusing all this time. We said that the base, which is in a green color, that the base was 12 feet. So I'm going to say A equals base is 12 feet times the height, which we did in the violet color, I think. The height is being represented by the number 7 feet. Now we can multiply these together. And 12 times 7 is, if I'm correct, ladies and gentlemen, right now, brain fart. 12 times 7, which is 84. Okay. And then multiply feet times feet, which is feet squared. So the area of this parallelogram is 84 feet squared. That means that we're going to find 84 squares inside of this parallelogram. And this is how we find the base and the height of these parallelograms, all right? Okay, here's a little look. Here's the introduction. Put it in here, okay? Try to keep it as simple as possible. This is your base, this is your height, base, and height, all right? If you need to look further for this, it's okay for you to pause and rewind. Okay, it's all good with that. Again, if you have any questions, please let me know, and I'll try to answer it as best as possible. Okay, I'm gonna ask you guys to flip your page. Okay, and this is the last part of the lesson. Okay, it says, draw and label the height of each parallelogram. Draw and label the height of each parallelogram. Use the correct mathematical tool to measure in inches, so that's our unit, in inches, in the base and height, and calculate the area of each parallelogram. Okay, so what it wants us to do, that the neat thing is that they gave us for free already the base. They're establishing that this bottom part, which for all of them, I'm going to use orange. This is our base. For this one, this is our base. And for this one, this is our base. Okay. They gave us that for free. What we need to find out is and label is our height, just like right here. Okay. You see how I labeled them base for all of them, and I also labeled them height. Okay. It's asking us to do that because it helps you guys. It's with the practice. Hopefully in the future you don't need to write down the words, but it's good for starting off right now. Okay. Quick look so that we can go to the back part. Okay. And we can jump and start challenging ourselves a little bit more. Okay. So if we look at the first one, okay, we have our base. You have two sides to choose from. You can either work from the left side of this, or you can work from the right side of this. From this case, it doesn't matter which side you choose. You can do the height here, or you can find the height here. Okay, it doesn't matter which side. All right, you guys, there's no problem with that. Me, myself, I'm feeling like a lefty today. Okay, so I'm gonna focus on the left. Okay, so I'm gonna kind of do a dotted line right there. And if you notice right here, it's making what type of angle? It's making a right angle. So I'm gonna put that little square right there. Okay, I'm gonna put that little square right there. It makes a right angle right there. I'm gonna use yellow, never mind. Baby blue, just to highlight that right there. And if you see right there, that makes your right angle. Okay, that's why we put that little square. Okay, and this right here, these dotted lines, we established that that's our height. Okay, same thing for this one. Okay, you can either, you have your base, you can either do your height here, or you can do it here. All right, I did it on the left side on this one. I'm gonna try this one on the right side. Okay, doesn't have to be perfect, it doesn't have to be neat. I'll try my best. Do a dotted line and then connect these right here, just so that it helps you see that this right here is our height. That's how tall the shape is. All right, you can see that's the height. It's basically saying from here to here. Okay, that's what the height is. How far is it from this parallel line to this parallel line? Same thing as this one. How far is from this parallel line to this parallel line? Height. Okay, and the last one more to go. Okay, again, you can focus, you can do the height here, or you can do it here. Okay, I'm gonna stick and do it right here for right now. Okay? It doesn't matter which one. Kind of maybe right there. Connect the dots. Sorry for my video skills, you guys. I'm not a really big phone user and recorder. I'm more of a teacher, but I'm trying my best. Okay, so there's kind of right there, you're able to see the height. You're trying to figure out how tall it's basically from here, from the top part to this bottom part, because if you look at it, it'll look diagonal, so it's easier to see from here to here. Okay, this is what we call our height. Remember, you could have also done it over here as well. Okay, you could have also said this, and I'm going to use a red color. Doesn't matter. And please, guys, okay, let's not get confused. Okay, I'm going to use this right here. Let's say, for example, I'm going to use the same shape. Kind of looks something like this, if I was correct. Okay, let's see. Let's compare. It looks somewhere similar. Okay, I decided here at the top, you notice I actually did it here. Just trying to prove to you that you can also do it here. You can go like that. It doesn't matter. Okay, it really doesn't matter. It doesn't matter what side you choose, as long as you're showing that they're connected. Boom. Okay. So you can either do it on the right side or like on this one on the left side, same thing here. You could have done it here, or you could have done it over. You could have done the height here or over here, right? Doesn't matter which side. Okay. So now we have established our bases and our heights. And I forgot to highlight the last one. That's our height. Okay. And it's saying us to use a correct mathematical tool to measure in inches. This is a correct mathematical tool, okay? Again, what we call a ruler, okay? And it's telling us to use in inches, so we flip it right here, okay? And if I were to measure the base, okay, in inches, that to me looks like 1.75 as the base. Okay, we don't want to focus on using decimals today. Since it's an introduction, I want to use whole numbers. So let's just call this, okay, not to scale again. And I'm going to be inventing, so I'm not going to be using this. Not inventing, I'm going to be inventing numbers and giving them to you guys. But we're just going to say that our base, and this is what I'm giving you guys, we're going to find the height and the base, the area. Let's say that the base is 4 inches and the height, and I'm going to put a little arrow right there to show the height because I don't have enough space. Let's say that the height is 1 inch. 1 inch. Okay. Well, let's find the area, which the formula is A equals base times height. All right. So let's see. So we have our A, which represents area. The area is, what's our base? In this case, I told you guys that the base, we were going to use it as 4. Multiply, that right there means multiplication. And our height is being represented with the number 1 inch. Okay, now we can multiply 4 times 1. Is 4, and inch times inch is 4 square inches. That's your area for that one. Okay, that's your area for that one. All right, let's look at the next one. Okay, we have our base and our height. For this one, I'm going to take it a little step further. We're going to say that the base for this one, which the base is right here. Okay, the base is right here. Let's say that the base is 9 inches. Okay, and the height, we're going to call the height, that is going to be 8 inches. All right, that's the height. So again, let's use the formula. And the formula again is A equals base times height. Okay, so we're going to, these are our variables. We're going to replace the variables. B, which is for base. We know that the base is 9 inches. We're going to replace the B with the number 9 inches. And we're going to multiply that times the height, which the height, which is H, we said that it's 8 inches. We're going to multiply times 8 inches. Now we can go in and plug these numbers and figure it out, solve it. 9 times 8, it's 72. And inches times inches is squared inches, or inches squared. All right, that's the area for that one. Okay, that's our practice. And then the last one. Okay, last practice, we're going to use this one right here. Okay, we're going to say that this one, that the base is 2 inches and that the height, which is from here to here, we're going to say that the height is 4 inches. All right, 4 inches. So let's use the formula again. A equals base times height. Okay, so the base, which is represented here, the base is 2 inches. So for the B, we're going to represent it with the number 2 inches. We're going to multiply the B with the H. So I'm putting the multiplication sign. And we know that the height, or H, is 4 inches. Now we can multiply, right? That's the operation going on right there, multiplication. Now we can multiply. And 2 times 4 is 8. Inches times inches equals inches squared. And that's your area for this parallelogram. So this is the proper form of how to find the area of these parallelograms. All right. practice problems just so you guys get them. And if you have any questions or concerns, let me know. Okay, again, through the video or email, shoot me a video if you want to, through Class Dojo. Okay, I know Class Dojo accepts the longest video, it's 8 minutes, so you can record a very short 30-second video just saying, Mr. Valencia, I don't get this part, or I need help with this step, or I get it, or blah, blah, blah. Whatever you have, feel free to ask me, okay? Feel free. That's why I'm here, you guys. You know that in my class, I want the best of the best, and you guys have proven to me every single day that you guys are the best of the best. And let's keep showing Academy del Sol that you guys are the best of the best, and keep showing your parents that you're the best of the best. We have one last problem, and then we're finished with the lesson, okay? Number 3, if the area of the parallelogram is 35 over 42 centimeters squared, and the height is 1/7 centimeter, write an equation that relates the height, base, and area of the parallelogram, and then solve your equation. So this is what I love to do. You guys notice this in classroom, okay? They're telling us that the area, and I'm gonna underline all this, the area of this parallelogram is this right here, 35 over 42 centimeters squared. So they already solved the problem for us. That's why I'm underlining it with, it seems like a yellowish greenish, that they solved it for us. And they're also giving us for free the height. Okay, so they're giving us, for example, this information, and they're giving us this, but they're not giving us our base. This is what it's missing. It's a giant question mark right now. What in the world is the base of this parallelogram? That's the number 3 on Mr. Valencia's problem. Okay, that's what we're gonna do. So what helps me out to figure out this problem, the first thing I do with my amazing drawing skills, I just try to draw a parallelogram. Does it have to be perfect? No, it doesn't, but it helps me to see it. So I would ask you guys to draw a parallelogram, something kind of like that. Okay, if you need to pause the video, okay? And I'm gonna use a red pen to show the height. Okay, so right there, kind of like in red. And they're telling us that the height of this parallelogram is 1/7 centimeter. Okay, so right here, this is the height, how tall it is, and it's saying that the height is 1/7 of a centimeter. Okay, this right here, this bottom part, we've established that this is the base, but we don't know what's the actual length of the base. Okay, we don't know what's the length of the base. Okay, we know that the area is 35 and 42 centimeters. That's what we know so far. So we got to figure out what can we do with these numbers that they gave us for free to figure out what's the base. So remember, this is the formula that we've been using. A equals base times height. Okay, we know that the area, we're going to replace the letter A. What's the area? It's 35 over 42. Remember, 35 over 42. Okay, that's the area. Equals base. We don't know what the base is, so we're going to leave it as B. And we know what the height is, which is the H, which the height happens to be, we label it right here, 1/7 times 1/7. Remember, guys, when we put parentheses, this means multiplication. I'm multiplying B times 1/7. It's the same thing as saying I'm going to do it here on the side. These are all saying the same thing. These are all saying the same thing. Okay? Believe it or not, these are all saying the same thing. These all means multiplication. And these are signs, by the way. I know my signs are horrible, but they're saying the same thing. So we're multiplying base times height, B times H. Okay? Now, remember, guys, in the practice before this COVID hit us, we were working on this new type of equations where we wanted to leave the variables by itself, okay? Because we want to know what the B, which is the base, is. So we need to leave B by itself. So we got to do something with this 1/7. And what do we got to do with that 1/7? We got to cancel it, right? So we're going to do the opposite of multiplication. So what's the opposite of multiplication? Well, the opposite of multiplication is division, right? They're twin brothers. The opposite of multiplication is division. And what happens with these? Okay, what happens with these? And you guys have told me over and over again, you sound like a choir now. Okay, trying to find an appropriate color to help see it. Since they're opposites, what happens with the opposites? And before we do that, what we're doing here, we're gonna do to this side as well. Okay, we're gonna do to this side as well. Okay. Okay, so we're gonna divide by 1/7 and we're gonna divide by 1/7. Okay. So far, so good. Okay. And I'm gonna leave it right there so you guys follow along. I know I told you to pause. Okay. So what happens with these ones? They cancel each other out. Okay. Now finally we have B by itself. So now we're in the process of almost finding what the base is. Now we have B and we bring this down. 1/7 divided by 35 over 42. We're almost done, you guys. This is probably the hardest problem. Okay. What we do with division here. Okay. This is one of the rules with division. We want to multiply. So we're going to make 1/7 and we're going to turn the 1/7 with its reciprocal. Okay. With its reciprocal. Okay. Which the reciprocal 1/7 is 7 or 7 over 1. Doesn't matter. And we're going to turn it times 35 over 42. Okay. And 35 times 7. Doing this for you guys. 35 times 7 is 245. And 1 times 42, we multiply across, is 42. So far, that's what we have. Okay, we have B equals 245 over 42. And I've told you guys in the past, we can't leave it like this. We have to reduce, right? We have to reduce. AZ Merit will ask us to reduce. So what we need to do here, what's going on here? Okay, what operation? This is not subtraction. This is not addition. It's not multiplication. This right here is division. So we're going to divide. Okay, we're going to divide. We're going to divide 42 by 245. Okay, and 42 does not fit into the 24. So now we have to say 42. How many times does it fit into the 245? Well, Mr. Valencia doing his mental math right now. It fits in 5 times. 42 times 5 is, this one I can't do mentally. That's 210. Okay. That's our leftover. So we have base. Bring it over here because I ran out of space. That's the only thing. And look at that one. We have 5. Base equals 5. Our remainder is 35. The remainder is the numerator. And the divisor, which is a 42, is our numerator. Sorry about that. That's a 42. It's hard to record and write at the same time. Now, we can't leave it like this either. We have to reduce. Both of these 35 and 42, they're factors of 7. So we can divide these by 7. Okay? V equals 5. And 35 divided by 7 is 5. And 42 divided by 7 is 6. So finally, we figured out that the base right here, this question mark, is no longer a question mark. And it's actually the base is 5 and 5, 6. And that's how you find it. It's a very long process, okay? Hopefully this video helps you with that. The hardest part is this right here, okay? Knowing what's the opposite of multiplication, you divide, and you're gonna do that to both sides, okay? That leaves the b by itself. So when I cancel here, it's like leaving it like this. So I bring it down, that's my b. Now I have that. Now what I can do is, to figure this out, you want to do the reciprocals, and since you're doing the opposite, you're also going to do the opposite of the symbols. You multiply, and then you get this. Then you want to divide, which is here, okay? And then I have my top, okay, which is my quotient. The 5 happens to be the big number, which is the whole number. The remainder, which is 35, is going to be my numerator. And the divisor, which is 42, is going to be my denominator. Now, in this case, I had to reduce. In this case, I'm emphasizing again, I had to reduce because these are multiples of 7. And you always want to reduce to lowest terms, or simplest terms is 5 and 5, 6. Okay, that's the lesson for today. Okay, finding the area of parallelograms through rectangle facts. Okay, if you have any questions or concerns with that, let me know as soon as possible. I'll be here available all day for you guys to answer any questions that you may have. Okay, this is your homework right here. Okay, just want to clarify what you guys have to do and what I'm asking. Okay, on question 1 and 2, it's only telling you guys to label, kind of like what we did here. Basically just labeling. So they gave you for free the base, okay? You are gonna have to label where the height is. So you're just gonna have to word the word height, but I do wanna see these little tick marks to show me where the height is. So for 1 and 2, you're gonna label where's the height, okay? For number 3, 4, 5, and 6, okay? You're gonna use the formula A equals base times height. So for example, you're gonna locate the base, or number 3 I'm getting you for free. Your base right here is 13, and your height is 6. So you're gonna multiply 13 times 6, okay? Make sure, again, you're finding the area. So since you're working with centimeters, your answer has to be centimeters squared, all right? Those are your units. You're gonna do the same thing with these ones. Base times height, base times height, base times height, okay? We go to the back. Okay, it's asking you a simple question. Is it saying that did they both use a correct method of doing this? Is it saying, are they correct? Yes or no? And explain your answer. Okay, so please explain your answer. I don't want it short. Yes, they're both right. No, they're both wrong. Or yes, Brittany is correct and Sid is wrong, or vice versa. Explain your answer. Okay, explain your answer. Number 8, do the rectangle and the parallelograms below have the same area? Okay. So you're going to try to find the area for this one, okay, which is length times width. And you're going to try to do the same for this one, base times height. If they come out the same, okay, let me know and explain why. And the last one, this is the very last problem that we actually did on the lesson, which is this one right here, okay? It's asking you guys, they gave you the actual area for free. They gave you the base for free, okay? Where you're trying to find is the height, okay? So what you're trying to find is the height for the last problem, which is this. You're going to have to go through this process, okay? They're giving you the area for free, okay? And the base, so you're going to have to do all this process again. If you have any questions with this one, let me know. I will more than happily help you. This is today's lesson, you guys, okay? If you're finished with it, or once you're finished with it, send it to me. All right, send it to me. Give you a shout out myself. I know you guys miss me. I miss you too. Look at my hair not looking good. Gotta switch this. Okay, send it to me. I will review it. I'll give you feedback on it. All right. If I think that you should fix a problem, I'll let you know to go back and fix a problem. Okay, or to rework on it, and I'll probably send you a video or some steps of how to work with that one, and then work on from there. If you feel comfortable with it and everything, again, tell your parents you can either take a picture of your work, okay? So for example, this was my homework. I would take a picture, okay? Take a picture, and what I actually need to picture more than everything, because these are more your notes, okay? These are morning notes. Take a picture of your homework, boom, boom, and send it to me through either Class Dojo, okay, or in my work email, which is that one, ivalencia@academydelsol.com. If you need to write it down, need more time, pause the video right now, okay, send it through there. Or you can actually also scan it, okay, so if you have a scanner at home, you can scan it and send it to me, again, either through my email or Class Dojo, okay. That's your option. Or there's some neat features now on iPhones and on Androids where certain apps can let you scan stuff, okay. You can also do that. If you need any help with that or tips with that, I can send you some links that will explain to you how to scan through your phone, okay. But picture is enough, all right? Just send me a picture of your stuff, I'll go over it. Make sure it has the last thing to go over it, okay. So I know, remember, I'm not in front of you guys, we're not in person together. Make sure right here, anywhere on the top, okay, write your name on it so I know who's sending it to me, and I can communicate to you guys either through email with your parents or Class Dojo, all right? Send it to me. Tomorrow I will be posting a video for lesson 2, okay. We will be doing lesson 2, and when I begin lesson 2, okay, I will begin you know, just like this one. Hopefully every video gets better. I want to get to a point where maybe I could do some live videos and then you guys can watch it later. So if you guys are along with me in the live video, I can answer questions. But for right now, this is our trial, okay? This was our lesson again, okay? I will be sending you guys, remember, you did do the integumentary system notes, okay? I will be giving you, you should have those notes, so I will be sending you later this week, maybe maybe tomorrow, or 2 days from now. Be sending you a video. I'm sorry, a video. I'll be sending your parents a link for the test, and you guys can open it, and you can either write down just the answers on one page and then send me the answers, whatever it is. But you guys have their notes for that, so I'm going to give you the integumentary system quiz. All right, this is the lesson for today. If you have any questions, okay, let me know. Again, either through email or Class Dojo. You can even send me a short video. I don't have to see your face. You want to record yourself, awesome. But you can record yourself and tell me, Mr. Valencia, I'm having trouble with this one. I don't get this step or something. It'll be more helpful to me to help you out. The more I know, the more I can help you, all right? So this is lesson 1. We're starting module 5, okay? Module 5 for 6th grade. We're already in 5 modules, you guys, so we've been doing an awesome job, all right? We want to destroy this AZ merit, or we call it AZM2 right now. I believe with you guys, even though we're isolated. I know we do great. You know, you guys, I believe in you every single day. You guys are awesome. You're amazing. I miss you guys. There's nothing like having your kids in front of you, okay? But, you know, we got to work with what we have. And I know that we'll do good. Every day we'll grow, we'll make better. Parents, students, send me any suggestions to make these videos better. You know, all I want to do is try to do quality instruction, even though I'm not in the classroom. You know, if I'm away, you know, get better with this. So this is, again, lesson 1. If you have any questions with these, let me know. And I'll be here for you guys. See you later.